Hello friends, welcome to my YouTube channel. So in today's video I will show you how to fit two curves simultaneously in origin. Okay, uh, you have seen uh, Hall resistivity and longitudinal resistivity. So actually what happens when we measure magnetoresistance of a crystal, and we have two kind of resistance. The first one in longitudinal direction is rho xx, and the second one in transverse direction, which is also known as Hall resistivity, is rho xy. So we get two different curves, and in order to have a detailed idea about the number of carriers and their mobility, we apply some models. We fit those curves, and we get these quantities. So okay, sometimes what happens, more than one carriers are involved in transport. Then we have to apply true carrier transport model. So this is paper for JEDAR SIS, and in which two carrier transport model was applied. And for similar kind of analysis, we should know how to fit two curves simultaneously. You can see in this paper they have measured rho xx, and rho xy, and they have fitted simultaneously in order to have idea of carriers. So here they have given formula for two carrier model. This is the formula for rho xx and rho xy. So what we do, we will write these formula in origin and try to fit some data. Means we want this kind of fitting. So this is formula for two carrier model. I have just copied from the paper, and what I have done, it is difficult to write nh mu h ne mu e, so I have replaced ne number of electrons by n, nh number of holes by p, and mu e electron mobility by c, and mu h hole mobility by d. And I have simplified this formula somewhat in same manner. Now I will add this formula to origin, and will try to show you how to fit some data based on these two formulas. So this is my data. This is magnetic field, and this is rho xx, and this is rho xy. So what I will do, I will select this data, go to analysis, fitting non-radial curve. And in function in category, we will select user defined, and I will try to add new function here. So I will name this function two carrier global fit. This kind of fitting is called global fit. That's why we put global fit. Independent variable is P, magnetic field. Dependent variable can be Y, and the parameters are small n, small p, small c, small d, and small t. No derived parameters are here, and also no constant. We have chosen small e for parameter. We can also put it to constant, but no problem. We will fix its value. Now we have to write formula here. Okay, so in global fit, we have to change little bit technique of writing. Suppose you see here, you have separate formula for rho xx and rho xy, so you have to combine these two formulas in a single equation. Okay, so what I have done, I have combined these two formulas in single equation. The rho xx is multiplied by parameter, yes, and rho xy is multiplied by parameter 1 minus x. What happens when we put s is equal to 1, then we will get only rho xx, and when we put s is equal to 0, then we get rho xy. So this technique we will use. I have to add another parameter, small s. So let's write this formula. So we have to write it here. Yes. Okay. So I have written this formula. You should be very careful at the time of writing this formula, and also I have checked this by setting some values, and this is correct according to me, so I can proceed. I will finish here. So now I have written the formula, and I will select data. So here I will select for global fit. This is data for rho xx and rho xy. This is code. This is formula which I want to fit, and I will select parameters. So the parameter is small n, small p, small c, small d, small e will be common in both of formulas. So I will put them as a shared variable, and the value of small e is fixed. It is 1.6 e minus 90. Okay, and the value of yes we will select fix as 1, and value of yes2 will be 0. Okay. Now I can start fitting. Things are okay. This is data. You can see. I will put approximate value of the number of electrons. So this is order of 24. The same amount of force will also be present around, and mobility is I think good, so we can start fitting now. So you can see the black curve is for rho xx, and the red one is for rho xy. So now I will run this for fitting. So you can set these values, fix these values according to your data, and the good initial value will give a best fitted curve. So this is the procedure for simultaneously two curve fitting. You can just fit it, and you can see a result of both fitting. So these you can see these are the shared variable rho xx and rho xy, and here this is the result of both fitting. This the first one is for rho xx and the second one is for rho xy. So this is the procedure for fitting of two curves simultaneously which have some common parameter. and this is quite useful in Hall resistivity. Okay, thanks for watching.